EDX Core Pure, Vectors 3, Equations of Planes, the angle between two planes. The angle between two planes can be found using the scalar product, rearranged to the form cos theta is A dot B over the magnitude of A times the magnitude of B. If we look carefully at the diagram, we can see that the angle between the two planes, which is theta, is exactly the same as the angle between the two normals, which will also be theta. So cos theta is normal n1 dotted with normal n2 over the product of the magnitudes of those normal vectors will give you the angle between the normals and therefore the angle between the two planes. So here we're going to find the acute angle between the two given planes. The planes are in Cartesian form, so the first thing I would recommend would be to write down the normal vector. So the first normal vector, we can get that from the coefficients of x, y, z, 2, minus 3, 1. And the normal vector for the second plane, again using the coefficients, 5, minus 2, minus 4. And if we dot these together, just to work out the value of n1 dotted with n2, we get 10 minus that's plus 6 minus 4 is 12. So I can now use the formula cos theta is n1 dotted with n2, which is 12, over the magnitude of n1. So using Pythagoras, that's 2 squared plus 3 squared plus 1 squared. So that would be the square root of 14. And the magnitude of n2, using 5 squared and 2 squared and 4 squared, is root 45. And therefore theta is 61.4 degrees. Notice we're in degrees to 3 significant figures. And there we can see the method in a little bit more detail. So now we're going to find the acute angle between these two planes, and notice one of them is in Cartesian form and one of them has been given in the form of r dotted with n equals k. So the first thing I would do here would be to pick out both normal vectors. So the first normal vector is going to be the coefficients of x, y, z, and the second normal vector is clearly the 4, minus 3, 5. I'm just going to dot them together first to work out what they are, what their value is. So that's 2 times 4, 2 times minus 3, and minus 5 times 5. So we get minus 23. So now when I use the formula for the angle between the planes, cos theta is the normal vectors dotted together, which is minus 23, over the magnitude of this first one, so that's 5 squared and 2 squared are 2 squared, is root 33, and the magnitude of the second normal vector, 5 squared, 3 squared, 4 squared, is root 50. So this minus 23, this negative value here, is an indicator that we are going to get an obtuse value for theta from this calculator. And indeed, we get theta is 124.5 degrees. And if we want the acute angle, which is asked for in the question, we would do angles on a straight line and simply quote 55.5 degrees. In the next session, we're going to be looking at the intersection of a line and a plane.